Hey guys, welcome back. Tonight, we're going to explore something that sounds almost too simple to be interesting. Emptiness. You've felt it before. An empty room. An empty road at night. The silence between sounds. But here's what most people never consider. The universe is almost entirely empty. Not partly empty. Not mostly empty. Almost completely empty. And when you truly understand what that emptiness means, what it feels like to exist inside it, it changes how you see everything around you. By the end of this journey, you'll understand what it actually means to exist inside the universe, and how small, slow, and patient most of it really is. Before we go any further, if you find this kind of calm exploration valuable, a like or subscribe genuinely helps the channel grow. It's a small thing for you, but it makes a real difference for me. And if you have thoughts or questions, leave a comment, but only if you actually enjoy this. Now dim the lights if you haven't already. Turn on a fan if that helps. Settle into wherever you are. Let your shoulders drop. Let the day release its grip on you. And let's begin. Let's start with something familiar. The room you're in right now. Look around. You see walls, furniture, objects. The air feels full. Light fills the space between things. If you reach out, you'll touch something solid within seconds. This is what we're used to. A world where matter is everywhere, where emptiness is the exception. But step outside that room. Step outside this planet. Step outside everything you've ever known. And emptiness becomes the rule. The nearest star is years away. Not hours, not months. Years, even for light itself. Between here and there, almost nothing exists. Just space, just distance, just time stretched across darkness. Have you ever wondered what that would feel like? Not as an astronaut on a mission with instruments and schedules, but as a quiet observer, surrounded by that distance. What does morning mean when there is no sunrise? How do you measure days when nothing changes? Could you stay calm inside that stillness, knowing help is light years away? Would you feel fear, or something closer to awe? And slowly, without quite noticing, you begin to drift. The room around you fades. The weight of the familiar lifts. You are no longer inside your life. You are floating somewhere much larger, much quieter, much older. This is the universe, and it has been waiting patiently to show you just how empty it really is. The moon is farther than you can survive. Thinking about the moon is 250,000 miles away. Light takes 1.3 seconds to get here from there. If the moon suddenly exploded right now, you would continue seeing it perfectly intact for 1.3 seconds while its pieces were already hurtling through space. That is the first real taste of cosmic time delay. The universe's quiet way of reminding you that your intuition means nothing out here. And the moon is close. The moon is practically sitting in your lap compared to everything else. Let that distance settle for a moment. 238,000 miles. If you drove to the moon at highway speed, say 60 miles per hour, no stops, no sleep, no existential breakdowns, it would take you roughly 5.5 months just to reach the thing you can see from your backyard on a clear night. The thing poets have written about for thousands of years. The thing that seems close enough to touch when it hangs low and orange on the horizon. It is not close. It has never been close. Your eyes have been lying to you your entire life. The Apollo astronauts took about 3 days to reach the moon. 3 days of coasting through absolute nothing. No air, no sound, no landmarks. Just the slow shrinking of Earth behind them and the slow growing of a gray, cratered world ahead. If something had gone wrong in the middle of that journey, and things very nearly did. Help was not coming. Mission Control could offer advice, but that advice would take 1.3 seconds to arrive, and their reply would take another 1.3 seconds to return. In an emergency measured in heartbeats, that delay is an eternity wearing a stopwatch. And here's the part that quietly unsettles most people when they truly consider it. Between Earth and the Moon, there is almost nothing. A few stray hydrogen atoms per cubic centimeter. Some dust. Cosmic rays passing through like ghosts who forgot where they were going. If you scooped up all the matter between here and there, you would not have enough to fill a thimble. The Moon floats in a sea of emptiness so complete that the word empty starts to feel inadequate. You could fit every other planet in the solar system, side by side, in that gap. Jupiter, Saturn, Uranus, Neptune, Mars, Venus, Mercury, all of them, lined up like beads on a string with room to spare. That is how much nothing exists between you and the nearest celestial body. And yet, when you look up at night, the Moon seems companionable, friendly even, a familiar face in the dark. It does not look like something separated from you by 250,000 miles of vacuum and silence. It looks like something you could reach if you only stretched a little further. This is the first lesson the universe teaches when you start paying attention. Distance is not what it appears. Your sense of near and far was built for savannas and forests, not for the gaps between worlds. Out here, close means something different. Out here, close still means impossibly, incomprehensibly far. And the Moon, patient and silver, continues its slow orbit, unaware that you are thinking about it, unaware that you exist at all. It has been circling Earth for 4.5 billion years. It will continue long after every human question has been asked and forgotten. So let that be your first glimpse of cosmic emptiness, the nearest neighbor, the closest companion, still separated from you by enough, nothing to swallow every planet you have ever heard of. And we have barely left home. Earth's atmosphere is a wet tissue in space. If you compressed the entire depth of Earth's atmosphere down to the thickness of a sheet of paper and then scaled the Earth to the size of a basketball, that paper would be too thin to measure. That is how fragile the blanket keeping you alive really is. Everything you have ever known, every breath, every storm, every sunset, exists inside that disappearingly thin film. Step just slightly beyond it, and you are already inside the void. Consider what the atmosphere actually does for you. It gives you air to breathe, a carefully balanced mixture of nitrogen and oxygen that your lungs have come to expect. It regulates temperature, keeping the planet from swinging between boiling days and freezing nights. It blocks most of the ultraviolet radiation that would otherwise cook your skin in minutes. It burns up the thousands of tiny meteoroids that rain down on Earth every single day, turning potential catastrophe into the pretty streaks you call shooting stars. And it does all of this while being almost nothing. The atmosphere extends roughly 62 miles above sea level. That sounds substantial until you remember that Earth's diameter is nearly 8,000 miles. The breathable part, the troposphere, where weather happens and planes fly and you spend your entire life, is only about 7 miles thick. If Earth were a globe sitting on your desk, you could not see the atmosphere. It would be thinner than a coat of varnish. This is what separates you from the vacuum of space. Not a wall, not a shield, a smear. Astronauts who have seen Earth from orbit often describe the atmosphere as unexpectedly delicate. A thin blue line curving along the horizon, a glow so faint it looks like it could be brushed away. They expected something more robust, something befitting the protection of 8 billion lives. Instead, they saw a whisper clinging to a rock. And that whisper is not evenly distributed. Half of all atmospheric mass exists below 18,000 feet, roughly the height of a modest mountain. Climb higher, and the air thins rapidly. By the time you reach the cruising altitude of a commercial jet, the pressure outside has dropped to a quarter of what it is at sea level. Step outside without protection, and you would lose consciousness in seconds. Not because space has arrived, but because the atmosphere is already giving up. The transition from something to nothing is not dramatic. It is gradual, quiet, almost polite. The molecules simply become fewer and fewer until, eventually, there are none. No boundary line, no door, just a slow fade into emptiness. Here is a thought that might keep you company as you drift. Every argument you have ever had happened inside that thin shell. Every song ever sung, every meal ever tasted, every breath drawn by every human who ever lived. All of it contained within a layer of gas so thin that from space it looks like condensation on a cold window. And beyond that condensation, nothing. The same nothing that stretches between planets. The same nothing that fills the gaps between stars. It begins just a short drive above your head, if your car could drive straight up, which it cannot, because the atmosphere would like a word with your engine first. You are sealed inside a bubble. The bubble is unimaginably thin, and the universe outside it is unimaginably vast. So breathe slowly tonight. Feel the air enter your lungs. That air is part of the tissue. That breath is proof you are still inside the only place where breathing is possible. And now, we drift a little further outward. The sun is a lonely god. The sun contains 99.86% of all mass in the solar system. Everything else, every planet, moon, asteroid, and comet, is just the remaining fraction of a percent scattered across a volume so vast that the sun itself becomes almost invisible from the edge. This is the first time you encounter true cosmic loneliness, a single burning sphere, holding almost everything, surrounded by almost nothing. Let those numbers breathe for a moment. 99.86%. That means Jupiter, the largest planet, the one we call a gas giant, the one with a storm bigger than Earth that has been raging for centuries. Jupiter is part of the leftover crumbs. Saturn with its rings, Neptune with its winds, Earth with its oceans and forests, and 8 billion people wondering about their place in the universe. All of it, combined, adds up to a rounding error. If the solar system were a bag of rice, the sun would be the rice. The planets would be a few grains stuck to the outside of the bag, and you would need a microscope to find them. The sun is massive enough to fit 1.3 million Earths inside it. If Earth were a peppercorn, the sun would be a beach ball. And not a small beach ball. The kind that takes real effort to inflate, the kind that blocks your view at a concert. That is the scale of the thing keeping you alive. A burning sphere so large that light itself takes over 4 seconds to travel around its equator. And yet, from the outer reaches of the solar system, the sun is just another star. Stand on Pluto. If standing on Pluto were something a person could casually do, and look back toward home. The sun would be bright, yes, brighter than any other point in the sky, but it would not look like the blazing disk you see from Earth. It would look like a very intense star, a brilliant pinprick, something you could cover with your thumb if your thumb were not frozen solid. From that distance, you would struggle to believe that single point of light contains almost everything, that it holds the gravitational leash of every planet, every asteroid, every chunk of ice drifting in the darkness, The sun's influence extends billions of miles, yet its presence from the edge feels almost modest. This is what cosmic loneliness looks like. A single object, responsible for nearly all the mass in its neighborhood, floating in a volume of space so incomprehensibly large that it might as well be alone. The planets are there, technically, but they are scattered so far apart, so thinly spread, that the sun could be forgiven for feeling like the only real thing in the room, and between the sun and those distant crumbs, nothing, vacuum, silence, emptiness so profound that a beam of light takes hours to cross it. The sun sends its light outward in every direction, and most of that light hits nothing at all. It simply travels forever, ignored, untouched, never warming anything. For every photon that lands on a planet, trillions more vanish into the void without purpose. The sun does not seem lonely from where you are lying. It seems overwhelming, too bright to look at, too warm to ignore. But that is because you are close. Cosmically speaking, you are standing right next to it. Step back far enough, and the sun becomes what it truly is, a single candle in an enormous empty cathedral, burning faithfully, holding almost everything, surrounded by almost nothing. And now, slowly, we drift a little further from its warmth. The space between planets would bore you to death. If you left Earth right now and traveled toward Mars at highway speed, say 70 miles per hour, it would take you roughly 600 years to arrive. 600 years of nothing. No rest stops, no scenery changes, just the slow crawl across a distance so empty that madness might feel like company. The planets look close together in diagrams. In reality, they are islands separated by oceans of pure nothing. You have been lied to by every classroom poster you have ever seen. Those colorful charts showing the solar system, the ones with the sun on one side and the planets lined up like polite students waiting for attendance. Those charts are beautiful. They are also deeply, fundamentally misleading. The planets are never that close together. They cannot be, or gravity would have torn them apart billions of years ago. The actual spacing between worlds is so vast that if those posters were drawn to scale, you would need a piece of paper stretching from your classroom to the next town over. And most of that paper would be blank. Consider the journey from Earth to Jupiter. At their closest approach, the two planets are still about 365 million miles apart. If you started walking today, assuming you could walk through space, which you cannot, but let us dream, you would need roughly 7 million years to arrive. That is not a typo. 7 million years of putting one foot in front of the other, and you would finally reach a planet that looks close enough to touch in a telescope. This is what the space between planets actually contains. Nothing you would notice. A few stray particles, some solar wind, charged particles streaming outward from the sun, invisible and silent, cosmic dust so sparse that you could travel for years without a single grain hitting your windshield. The void between worlds is not just empty, it is aggressively, almost insultingly empty. And yet, spacecraft cross these distances regularly. The trick is patience. A spacecraft heading to Mars does not fly in a straight line. It arcs outward, matching orbits, falling toward its destination rather than charging at it. The journey takes 6 to 9 months, depending on the alignment of the planets. During that time, the spacecraft is completely alone. No rescue missions, no course corrections from the ground that arrive instantly. Just a metal box drifting through an emptiness so complete that the word silence does not do it justice. Silence implies the absence of sound. This is the absence of everything. Here is a thought experiment for your drifting mind. Imagine yourself inside one of those spacecraft. You wake up after launch. The excitement of leaving Earth has faded. You look out the window and see nothing. You check again the next day. Still nothing. A week passes, a month. The view does not change because there is nothing to change. No landmarks, no weather. Just the same stars, impossibly far away, offering no sense of motion whatsoever. This is interplanetary boredom, the kind of boredom that does not build character. It simply exists, vast and patient, waiting for you to fill it with whatever thoughts you can muster. And the distances only grow larger from here. Mars is practically a neighbor. Jupiter is a long commute. Saturn, Uranus, Neptune, each one requires years of travel, even for our fastest machines. Voyager 1, launched in 1977, is still out there, still crossing the space between things, still surrounded by emptiness that makes the Earth to Mars gap look like a crack in the sidewalk. So the next time you glance at a diagram of the solar system, remember what it is hiding. The planets are real. The spaces between them are realer, and those spaces are very, very quiet. Now, we drift a little further still. Alpha Centauri is next door and still impossible. Alpha Centauri is 4.3 light-years away. Our fastest spacecraft ever launched would take roughly 73,000 years to get there. In cosmic terms, this is our next-door neighbor. In human terms, it is forever. This is the distance where close and unreachable become the same word. You could wave at it your entire life, and the light from your hand would still be traveling long after your great-great-grandchildren had forgotten your name. Let that timeline settle into your bones for a moment. 73,000 years. That is longer than modern humans have been painting on cave walls, longer than agriculture, longer than every empire that has risen and fallen and been forgotten. If we had launched a spacecraft toward Alpha Centauri when the first humans were crossing into Europe during the Ice Age, that spacecraft would not have arrived yet. It would still be out there, drifting, alone, with tens of thousands of years left to go. And this is the closest star system to our own. Alpha Centauri is actually 3 stars, a binary pair called Alpha Centauri A and B, plus a smaller red dwarf named Proxima Centauri, which is technically the closest of the 3. Proxima even has a planet orbiting in what scientists call the habitable zone, a rocky world where liquid water might exist, a place that, in a different universe with different physics, might be somewhere we could visit. But we cannot visit. Not really. Not with any technology we currently possess or can reasonably imagine building. The problem is not willpower. It is not funding. It is not even engineering, though the engineering challenges are staggering. The problem is distance itself. 4.3 light-years translates to roughly 25 trillion miles. That number is so large it stops meaning anything. Your brain cannot hold 25 trillion of anything. It just becomes a word, a placeholder for incomprehensibly far. Here is another way to think about it. Light is the fastest thing in the universe. Nothing moves quicker. And yet, light leaving Alpha Centauri right now will not reach your eyes for 4.3 years. If that star exploded tonight, ceased to exist in a violent, brilliant flash, you would have no idea until 2029. You would continue seeing its steady glow, watching a ghost, completely unaware that the source had already vanished. This is the universe's sense of humor. It shows you things that no longer exist. It hides the present behind the speed of light and dares you to figure out what is real. Now imagine sending a message to Alpha Centauri, a simple radio signal traveling at the speed of light. it would take 4.3 years to arrive. If someone or something received it and immediately replied, you would wait another 4.3 years for the response. A single exchange of hellos would take nearly a decade. A conversation would take a lifetime. By the time you received your 10th reply, you might no longer remember what you originally asked. This is what close means in the cosmos. Close means you can see it. Close means it has a name. Close does not mean you can touch it, reach it, or ever truly know it. And beyond Alpha Centauri, the distances only grow. The next nearest stars are even further. 6 light years, 10 light years, dozens. The galaxy stretches 100,000 light years from edge to edge. Alpha Centauri is not just our neighbor. It is the first step on a staircase so tall that the top is not visible from where we stand. So tonight, as you drift, picture that faint point of light in the southern sky. It is real. It is burning. It has planets. And it is so far away that close and impossible have learned to share the same address. Now, we drift inward for a moment, toward something smaller, toward you. What you are made of is mostly nothing. If you removed all the empty space inside every atom in your body, you would collapse into a particle smaller than a grain of sand. The chair beneath you, the walls around you, the ground under everything, almost entirely empty. Solidity is an illusion your atoms agree to perform for you. You are quite literally made of nothing pretending to be something. This might be the strangest truth you encounter tonight. You feel solid. You feel like a thing, a real physical presence taking up space in the world. When you press your hand against a table, there is resistance. When you lie down, the mattress holds you up. Physics seems to confirm what your senses already know. You are here. You are real. You are made of stuff. But the stuff is mostly empty. An atom, at its core, is a tiny nucleus surrounded by a cloud of electrons. The nucleus contains nearly all the atom's mass. Protons and neutrons packed together in an almost impossibly small space. The electrons orbit at a distance that, relative to the size of the nucleus, is enormous. If the nucleus of a hydrogen atom were the size of a marble, the electron would be orbiting nearly half a mile away. And in between, nothing. Just empty space. No substance. No filler. Just distance. This is what you are made of. Trillions upon trillions of atoms, each one a tiny solar system with a dense center and a vast empty expanse surrounding it. If you could somehow remove all that empty space, push every nucleus and electron together until they actually touched, the entire human race would fit inside a sugar cube. Not your town, not your country. Every human being who has ever lived, compressed into a volume smaller than something you stir into coffee. So why do you feel solid? The answer is forces, not matter. When your hand touches a table, you are not actually touching the table. The electrons in your skin are repelling the electrons in the wood. Electromagnetic force is pushing back against you, creating the sensation of contact. You have never truly touched anything in your life. You have only felt forces pretending to be surfaces. This is the illusion your atoms perform every moment of every day. They convince you that you are solid, that the world is solid, that there is something where there is almost entirely nothing. And they do it so convincingly that you never question it. You walk on floors that are mostly empty space. You drink water that is mostly empty space. You love people who are, at the atomic level, almost entirely void. Here is where it becomes beautiful instead of unsettling. The emptiness inside you is not a flaw. It is what allows you to exist. If atoms were truly solid, packed tight with no space between, chemistry would not work. Molecules could not form. Bonds could not bend and flex and rearrange. Life requires the emptiness. The gaps are not absences. They are architecture. You are a cathedral of nothing, held together by forces invisible to everything except their effects. And somehow, that cathedral is lying in bed right now, listening to a story about the universe, wondering if any of this is real. It is real, just not in the way your senses suggest. Now, slowly, we drift outward again, past your atoms, past the earth, past the warmth of familiar things, toward the cold edges where the sun's influence fades and the true emptiness begins. The Oort cloud is a ghost neighborhood. At the outer edge of our solar system lies the Oort cloud, a theoretical shell of icy objects so far from the sun that light takes over a year to reach it. If the sun were the size of a grain of sand in New York City, the Oort cloud would stretch past Los Angeles. And within that unimaginable distance, objects are so spread out that you could travel for centuries without bumping into one. It is less a cloud and more a rumor of matter. No one has ever seen the Oort cloud directly. We know it exists, or at least we are fairly certain it exists, because of comets. Long-period comets, the ones that sweep through the inner solar system once every few thousand years, have orbits that trace back to an origin impossibly far from the sun. Something out there must be holding them, storing them, occasionally nudging them inward. The Oort cloud is our best explanation. A vast, spherical shell of frozen leftovers from the birth of the solar system, drifting in the darkness at the very edge of the sun's gravitational reach. But calling it a cloud is generous. The word cloud suggests density. It suggests substance. It implies that if you traveled there, you would find yourself surrounded by something, ice and rock and ancient debris, floating close enough to observe. The reality is far lonelier. The Oort cloud may contain trillions of objects, but those objects are spread across a volume so immense that the average distance between them is millions of miles. You could spend your entire life out there and never see a single one. Imagine walking through a desert, not a desert with dunes and cacti and the occasional vulture circling overhead, a desert so vast that you could walk for 1,000 years and never encounter a single grain of sand. That is the Oort cloud. It is a desert made of almost nothing, named after the few grains that might theoretically exist somewhere within it. The distances involved are difficult to express in terms that mean anything. The inner edge of the Oort cloud is thought to begin around 2,000 astronomical units from the sun. 1 astronomical unit is the distance from Earth to the sun, about 93 million miles. So the inner edge starts at roughly 186 billion miles away. The outer edge may extend to 100,000 astronomical units or more. At that distance, the sun would be just another star. Bright, yes, but no longer obviously special, no longer obviously yours. Light from the sun takes about 8 minutes to reach Earth. It takes over 5 hours to reach Pluto. It takes more than a year to reach the Oort cloud's inner boundary. And it takes nearly 2 years to reach the outer edges, if those edges even exist in the way we imagine. This is the solar system's attic, the forgotten storage space where the universe put things it did not know what to do with. And yet, occasionally, something stirs out there. A passing star drifts close enough, still light years away but close by cosmic standards, and its gravity gently tugs on one of those frozen wanderers. The object's orbit shifts. It begins a slow fall inward toward the sun, toward warmth it has not felt in billions of years. Thousands of centuries later, it arrives in the inner solar system, sprouts a tail, and becomes a comet. A brief, brilliant visitor from the ghost neighborhood. Then it is gone, back into the dark, back into the empty. The Oort cloud does not care that you know about it. It does not care that scientists named it. It simply drifts, cold and patient, holding its frozen secrets at the edge of everything we call home. And beyond it, true interstellar space begins. Now, slowly, we cross that threshold, into the space between stars, into the silence that has no end. Interstellar space is where silence lives. Once you leave the influence of any star, you enter interstellar space, the vast stretches between solar systems where almost nothing exists. Temperatures hover just above absolute zero. Light from distant suns is faint enough to forget. If you screamed, the sound would have nowhere to go. This is the default state of the universe, not the exception, the rule. And it stretches on for trillions upon trillions of miles in every direction. Only 2 human-made objects have ever reached this place. Voyager 1 crossed into interstellar space in 2012 after 35 years of traveling. Voyager 2 followed in 2018. Both spacecraft are still out there, still drifting, still sending faint signals back to Earth, though those signals take over 22 hours to arrive. They are the most distant things humanity has ever created. And yet, in terms of the journey to the nearest star, they have barely taken their first step. Interstellar space is what happens when you leave everything behind. There is no sun warming your back, no planets to aim for, no moons, no asteroids, no landmarks of any kind. Just void. The density of matter out here is roughly 1 atom per cubic centimeter. To put that in perspective, the air you are breathing right now contains approximately 27 quintillion molecules per cubic centimeter. Interstellar space is emptier than the best vacuum humans have ever created in a laboratory, and it is cold, unimaginably cold. The temperature of interstellar space hovers around 2.7 Kelvin, roughly minus 455 degrees Fahrenheit. This is just a few degrees above absolute zero, the theoretical point at which all molecular motion stops. At this temperature, the cold does not bite. It does not sting. It simply exists, patient and absolute, waiting for any warmth to radiate away into the darkness. If you found yourself out here without protection, you would not freeze instantly. That is a common misconception. Space is such a good insulator because there is nothing to conduct heat away, that you would actually die of oxygen deprivation long before the cold took you. Your body would radiate heat slowly, like a cup of coffee cooling in an empty room. The emptiness would not kill you quickly. It would simply wait. Sound cannot exist here. Sound requires a medium, air, water, something to carry the vibrations from one place to another. In interstellar space, there is no medium. If you clapped your hands, you would feel them come together, but you would hear nothing. If a star exploded nearby, relatively nearby, meaning light years away, you would see the flash. You would feel radiation if you were close enough, but you would never hear a thing. The universe's most violent events occur in perfect silence. This is perhaps the hardest part for human minds to accept. We are creatures of sound. We evolved in a world of rustling leaves, distant thunder, voices calling across open plains. Silence to us means something is wrong. But out here, silence is simply the natural state. It is not empty in a sad way. It is empty in a factual way. This is just what the universe is, almost everywhere, almost always. And interstellar space stretches on without end. Between our solar system and Alpha Centauri lies 4.3 light years of this emptiness. Between Alpha Centauri and the next star, more emptiness. Between all the stars, in every direction, the same profound quiet. If you could travel faster than any human technology allows, you would still spend most of your journey surrounded by nothing at all. Voyager 1 is out there right now, carrying a golden record full of human sounds, music, greetings, the noise of a world it will never see again. Those sounds cannot play in the void, but they travel through it, waiting for an ear that may never come. Now, slowly, we pull back further, to see the shape of the emptiness itself. The Milky Way is mostly holes. Our galaxy contains somewhere between 100 billion and 400 billion stars. That sounds crowded until you realize the Milky Way is 100,000 light years across. If you placed every star in our galaxy as a grain of sand and spread them across that distance to scale, the average gap between grains would be miles. Our galaxy is not a glittering city. It is a desert with occasional very distant campfires. The numbers are designed to impress you, and they do. Hundreds of billions of stars, more suns than grains of sand on all of Earth's beaches, according to some popular comparisons. It sounds impossibly full, a galaxy bursting with light and matter and possibility. But then you remember the distances. The Milky Way is a disk roughly 100,000 light years in diameter and about 1,000 light years thick. That means if you could travel at the speed of light, which you cannot, it would still take you 100,000 years to cross from one side to the other. And during that journey, you would pass by remarkably little. The average distance between stars in our galaxy is about 5 light years. Some regions are denser, like the crowded core where ancient stars huddle close together. Some regions are sparser, like the galactic outskirts where stars drift alone in the dark. But on average, 5 light years of nothing separates each point of light from its nearest neighbor. 5 light years, nearly 30 trillion miles, and that is the average. Here is an analogy that might help your drifting mind. Imagine a model of the Milky Way where each star is represented by a single grain of sand, a small grain, maybe a millimeter across. If you wanted to space those grains correctly to match the real proportions of the galaxy, you would need to place them roughly 3 miles apart. 3 miles of empty air between each grain. Now do that 200 billion times. Your model would stretch across an area larger than the continental United States, and almost all of it would contain nothing at all. You could walk through this model for days and never encounter a single grain of sand. The stars would be real, but finding them would feel nearly impossible. This is the Milky Way. Not a dense river of light, but a vast emptiness occasionally interrupted by fusion. When you look up at the night sky and see the pale band stretching overhead, the faint glow that ancient people named for spilled milk, you are not seeing stars pressed together. You are seeing the combined light of billions of stars too far apart to distinguish individually. Your eyes blend them into a smear, and that smear becomes beautiful. But the beauty hides the truth. Those stars are alone. Each one burns in its own private bubble of space, separated from its neighbors by distances that would take thousands of human lifetimes to cross. If a star on one side of the galaxy exploded tonight, stars on the other side would not know about it for 100,000 years. The galaxy does not communicate with itself in any time frame that matters to living things. And yet, somehow, this emptiness holds together. Gravity, the weakest force in the universe, yet the one with the longest reach, binds these distant campfires into a single, slowly spinning structure. The Milky Way rotates once every 225 million years. Dinosaurs lived during the last galactic rotation. The one before that, complex life on Earth had barely begun. The galaxy is patient because it has no choice. Emptiness enforces slowness. Distance demands time. So when you picture your home galaxy tonight, do not imagine a crowded city of stars. Imagine a vast, quiet prairie, stretching in every direction, with a single candle burning every few miles. And between those candles, nothing but night. Now, slowly, we drift further outward, past the edges of our galaxy, into the space between islands of light. Galaxies are lonely islands, drifting apart. The nearest major galaxy to us, Andromeda, is 2.5 million light-years away. Between here and there, almost nothing exists. A few dwarf galaxies, some stray stars, but mostly emptiness so profound it does not even have a color. And this is considered close. Most galaxies are so far apart that they will never interact, never touch, never know each other existed. When you look at the Andromeda galaxy, and you can see it with your naked eye on a clear, dark night, you are looking at light that left its source 2.5 million years ago, before humans existed, before our ancestors had discovered fire. That light has been traveling through the void since the early Pleistocene, crossing emptiness so complete that nothing interrupted its journey until it landed softly on your retina. And Andromeda is our neighbor. The Milky Way and Andromeda are part of a small collection of galaxies called the Local Group, a cosmic neighborhood containing about 80 galaxies bound together by gravity. That sounds almost cozy until you realize those 80 galaxies are scattered across roughly 10 million light-years of space. Most of them are small, dwarf galaxies with only a few billion stars, orbiting the larger spirals like moths around distant lamps. Between these galaxies, intergalactic space stretches empty and cold. If interstellar space is quiet, intergalactic space is silent beyond comprehension. The density of matter out there drops to nearly nothing, perhaps 1 atom per cubic meter, compared to 1 atom per cubic centimeter between stars. The void between galaxies is 1,000 times emptier than the void between suns. And it is dark, truly, absolutely dark. In interstellar space, you can at least see stars in every direction. Faint, yes, but present. In intergalactic space, you would see galaxies, but they would appear as smudges, not points of light. The distance would reduce entire civilizations, entire histories, entire cosmic dramas to pale blurs barely distinguishable from the background. Here is something that might comfort you or unsettle you, depending on your mood. Andromeda is moving toward us, not slowly. It is approaching at roughly 250,000 miles per hour, fast enough to cross the distance between Earth and the Moon in about an hour. In approximately 4.5 billion years, the Milky Way and Andromeda will collide. But collide is the wrong word. When galaxies merge, almost nothing actually touches. The stars are so spread out, the distance is so vast, that 2 galaxies can pass through each other like ghosts walking through walls. Some orbits will shift. Some stars will be flung outward into intergalactic space, doomed to wander alone forever. But the odds of any 2 stars actually colliding are vanishingly small. The emptiness protects everything, even during a catastrophe. Beyond the local group, other galaxy groups and clusters float in the void. Some are tens of millions of light years away. Some are hundreds of millions. And beyond those, more galaxies, more clusters stretching to the edge of the observable universe, a sphere roughly 93 billion light years in diameter, containing an estimated 2 trillion galaxies, 2 trillion islands, each one containing billions of stars, each one separated from its neighbors by gulfs so vast that light itself grows tired crossing them. Most of these galaxies will never meet. The universe is expanding, Space itself is stretching, and the distant galaxies are receding faster every day. Some are already beyond our reach. Their light will never arrive. Their stories will never be known. They are out there, they are real, and they are forever alone. Now we drift toward something even emptier, a place where the nothing becomes almost absolute. The Buddha's void could swallow everything you know. There is a region of space called the Buddha's void. It is roughly 330 million light-years across and contains almost nothing. Not almost nothing by space standards, almost nothing by any standard. Fewer than 60 galaxies exist inside a volume that should hold thousands. If our Milky Way had formed in the center of the Buddha's void, we would not have known other galaxies existed until the 1960s. That is how empty can be. The Buddha's void was discovered in 1981, and it disturbed astronomers immediately. Not because voids are unusual. The universe is full of empty regions between galaxy clusters, like bubbles in cosmic foam. But the Buddha's void was different. It was too empty, too large, too perfectly hollow, a sphere of almost nothing, sitting in the constellation Boötes, like a hole punched through the fabric of everything. To understand how strange this is, you need to understand what normal looks like. In a typical region of space, galaxies cluster along filaments, long, thread-like structures that weave through the cosmos like a three-dimensional spiderweb. Between these filaments, voids form naturally. Empty pockets where gravity never gathered enough matter to build galaxies. These voids are common. They are expected. They are part of the universe's architecture. But most voids contain something. Stray galaxies, dwarf systems, leftovers from the early universe that never quite coalesced into larger structures. The Buddha's void contains almost none of this. 60 galaxies in a volume that should hold 2,000 or more. Imagine a city the size of Texas with only 60 people living in it. Not 60 per neighborhood, not 60 per block, 60 total, scattered across an area larger than most countries. That is the Buddha's void. And here is where it becomes almost philosophical. If Earth had formed inside the Buddha's void, if our solar system had coalesced in that emptiness instead of here, human history would have unfolded very differently. For most of our existence, we would have looked up at the night sky and seen only stars from our own galaxy. The Milky Way would have been everything. Beyond it, nothing but darkness. We would not have discovered other galaxies until our telescopes became powerful enough to peer across hundreds of millions of light years. That did not happen until the mid-20th century. For all of human history before that, we would have believed we were alone. Not just alone as a species, alone as a galaxy. The only island of light in an infinite sea of black. The loneliness of that thought is difficult to hold. We are lucky, in a way. Our cosmic address places us in a relatively crowded neighborhood. We can see Andromeda with our naked eyes. We discovered the existence of other galaxies in the 1920s, when Edwin Hubble proved that the smudges in our telescopes were not nebulae within the Milky Way, but separate galaxies entirely. That discovery changed everything. It told us the universe was larger than we had ever imagined. But if we had lived in the Buddha's void, that revelation would have been delayed by decades, perhaps longer. The void does not care about this, of course. It does not know it is empty. It simply exists, a vast, quiet bubble where gravity forgot to do its work. Light crosses it eventually. Time passes within it, presumably. But nothing much happens there, and nothing much will happen there for billions of years to come. Some astronomers have speculated about the Buddha's void's origin. Perhaps it formed from the merger of smaller voids, empty regions combining into one enormous hollow. Perhaps something about the early universe's conditions prevented matter from gathering there. No one knows for certain. What we do know is that the Botha's void is real, it is vast, and it is almost perfectly empty. A reminder that the universe does not owe us company, that emptiness is not a flaw in the design, it is the design. Now slowly, we drift toward things we cannot see at all. Dark matter fills the gaps you cannot see roughly. 27% of the universe is dark matter, something we cannot see, touch, or detect directly. It does not interact with light. It passes through everything. We only know it exists because galaxies spin in ways that visible matter alone cannot explain. So even in the emptiness, something invisible may be drifting alongside you. The universe is not just empty, it is mysteriously empty. Here is the problem that started everything. In the 1930s, an astronomer named Fritz Zwicky was studying a cluster of galaxies when he noticed something strange. The galaxies were moving too fast. Based on the visible matter he could see, all those billions of stars, there was not enough gravity to hold the cluster together. The galaxies should have been flying apart, scattering into the void like seeds blown from a dandelion. But they were not. Something invisible was holding them in place. Zwicky called this missing substance dark matter, and then the scientific community mostly ignored him for decades. He was eccentric. His idea was strange, and besides, there had to be a simpler explanation. There was not. By the 1970s, astronomer Vera Rubin was studying the rotation of spiral galaxies and finding the same impossible result. The outer edges of galaxies were spinning just as fast as the inner regions. This should not happen. In any normal system, like our solar system, objects farther from the center move slower. Mercury orbits the Sun faster than Neptune. This is basic physics. But galaxies did not follow basic physics. Their outer stars moved as if something massive and invisible was surrounding them, adding gravity that the visible matter could not account for. Dark matter became the answer no one wanted, but everyone needed. Here is what we know about dark matter, which is distressingly little. It has mass. It exerts gravitational pull. It does not emit light, absorb light, or interact with light in any way we can detect. It passes through ordinary matter like a ghost walking through walls. Right now, as you lie there, dark matter particles may be drifting through your body, through the atoms that make you, through the bed beneath you, through the earth itself, without touching anything. You would never know. You could never know. Dark matter does not interact with the electromagnetic force, which means it does not interact with anything we use to see or touch or measure the world. It is invisible in the most complete sense of the word. We cannot build a detector that catches it directly. We can only infer its presence by watching how visible matter behaves in its presence. This is like noticing that trees are bending in a wind you cannot feel, and concluding that the wind must exist. And dark matter is not rare. It makes up roughly 27% of the total mass energy of the universe. Ordinary matter, the stuff you are made of, the stuff stars and planets and galaxies are made of, accounts for only about 5%. You are part of the minority. You are the exception, not the rule. For every atom in the universe, there is 5 times as much dark matter, and we have no idea what it actually is. Scientists have theories. Some believe dark matter is made of undiscovered particles, weakly interacting massive particles, or WIMPs, which sounds like an insult, but is actually a genuine scientific term. Others suggest it could be primordial black holes, or axions, or something else entirely. Experiments around the world are searching for direct evidence, hoping to catch a dark matter particle in the act of doing something. So far, nothing conclusive. The universe is filled with something we cannot see, cannot touch, and cannot explain. It surrounds every galaxy. It drifts through every void. It is here, in this room, passing through you as you breathe. And we do not know what it is. The emptiness of space is strange enough, but knowing that the emptiness is filled with invisible mystery makes it stranger still. Now, slowly, we turn towards something even more elusive, something that is not just filling the gaps, but actively pushing everything apart. Dark energy is pushing everything apart. Approximately 68% of the universe is dark energy, a force we understand even less than dark matter. It is causing the universe to expand faster and faster. Galaxies that are distant now will eventually accelerate beyond our ability to see them. The emptiness is not staying still. It is growing. The gaps are widening while you sleep. If dark matter is a mystery, dark energy is an enigma wrapped in a question mark and set on fire. We know it exists because of what the universe is doing. In 1998, two teams of astronomers were studying distant supernovae, exploding stars that can be used as cosmic measuring sticks, when they discovered something that should not have been possible. The universe was not just expanding, it was accelerating. This was wrong. It violated expectations. After the Big Bang, gravity should have been slowly pulling everything back together, or at least slowing the expansion down. Instead, the expansion was speeding up, as if something was pressing the accelerator pedal harder with every passing billion years. That something is what we now call dark energy. Here is how little we understand it. Dark energy makes up roughly 68% of the universe, and we cannot explain what it is, where it comes from, or why it behaves the way it does. It is the dominant force shaping the fate of everything, and it remains almost completely opaque to human understanding. What we do know is what it does. Dark energy is pushing space itself apart, not pushing galaxies through space, like a wind blowing leaves across a yard, pushing the fabric of space itself, stretching the distance between everything. Galaxies are not flying away from each other because they have momentum. They are getting farther apart because the space between them is literally growing. This is why the universe can expand faster than light without violating physics. Nothing is moving faster than light. Space is simply creating more of itself, and the distance increases as a result, and it is accelerating. The farther away a galaxy is, the faster it appears to be receding. Some galaxies are already moving away from us faster than light can travel. Their light will never reach us. No signal they send will ever arrive. They are beyond our cosmic horizon, and they are getting more beyond it every moment. In the distant future, this will change everything. Imagine a civilization arising billions of years from now, long after our sun has died. They look up at their night sky, and they see almost nothing, just their own galaxy, isolated and alone. All the other galaxies have receded so far, so fast, that their light can no longer reach this future world. The evidence of the Big Bang will be gone. The cosmic microwave background will have stretched beyond detection. The universe will appear static and eternal. This future civilization will have no way of knowing what we know now. They will not understand that the universe is expanding. They will not know that trillions of galaxies once filled the sky. They will look at the emptiness and assume it was always this way. The universe will have erased its own history. This is what dark energy is doing, slowly, patiently, while you sleep. It is pulling everything apart. It is widening the gaps. It is making the emptiness emptier, and there is nothing to stop it. Some cosmologists find this comforting, a gentle fading into quiet darkness. Others find it melancholy, the ultimate loneliness waiting at the end of time. But regardless of how it makes you feel, it is happening. Right now, right here. The space between galaxies is growing larger by the second. You will not notice. The expansion is far too slow on human scales, far too subtle to measure without instruments and centuries of observation. But it is real. The universe is getting emptier, and it will never stop. Now, slowly, we drift toward the spaces within the emptiness, to ask what nothing actually contains. What nothing actually contains. Empty space is not truly empty. At the quantum level, particles pop in and out of existence constantly. Virtual particles flickering like static on a television tuned to no channel. The vacuum seethes with potential, borrowing energy from the universe for fractions of a second before repaying the debt. Nothing, it turns out, is surprisingly busy when you look closely enough. But from where you sit, drifting through this story, it all looks perfectly still. This is one of the strangest truths physics has ever uncovered. When you imagine empty space, true vacuum, with all the matter and energy removed, you probably picture stillness, darkness, absolute quiet, a void with nothing happening because there is nothing there to happen. But that is not what emptiness looks like at the smallest scales. Quantum mechanics tells us that the vacuum is not calm. It is restless. It seethes with activity, even when there is nothing there in the traditional sense. Pairs of particles, a particle and its antiparticle twin, pop into existence from nothing, exist for an unimaginably brief moment, and then annihilate each other before the universe can notice the debt. These are called virtual particles, and they are everywhere, right now, in the space between your hand and your face, in the void between stars, in the emptiest reaches of intergalactic space. The vacuum is never truly at rest. This sounds like science fiction, but it has been measured. In 1948, a Dutch physicist named Hendrik Casimir predicted that if you placed two metal plates extremely close together in a vacuum, the virtual particles between them would create a measurable force, pushing the plates together ever so slightly. This is now called the Casimir effect, and it has been confirmed in laboratories around the world. Nothing is pushing something. Emptiness has a force. Here is where it becomes difficult to hold in your mind. Virtual particles exist for durations so short that time itself barely registers them. They appear, interact, and vanish in spans measured in fractions of a second, so small there is no human experience to compare them to. If you tried to observe them directly, the act of observation would change them. They are ghosts that only exist when no one is looking, and yet they matter. Virtual particles are not just theoretical curiosities. They affect the behavior of real particles. They contribute to the mass of protons and neutrons. They influence the way atoms interact with light. The vacuum's constant flickering is woven into the fabric of physics, a background hum that never stops, even in the emptiest places imaginable. Some physicists believe that dark energy, the mysterious force pushing the universe apart, might be related to this vacuum energy. The calculations do not quite work yet. When scientists try to predict how much energy the vacuum should contain, they get a number that is wildly, absurdly too large, by a factor of 10 to the power of 120. This is the largest discrepancy between theory and observation in all of physics. Something is wrong with our understanding, or something is missing. But even without solving that mystery, we know this much. Emptiness is not what it appears. The nothing between things is doing something, always. It is lending particles to reality and taking them back. It is fluctuating, vibrating, humming with potential. You cannot hear it. You cannot see it. You cannot feel it in any way your body is designed to sense. But it is there, beneath everything, making nothing into something over and over again. So when you picture the void tonight, the vast, cold reaches between stars and galaxies, do not imagine perfect stillness. Imagine a quiet buzz, a faint shimmer, the universe breathing in and out at scales too small to comprehend. Nothing is never really nothing. Now slowly, we drift toward the cold, toward the temperature of the void itself. Temperature in the void. The average temperature of empty space is about 2.7 Kelvin, roughly minus 455 degrees Fahrenheit. That is just slightly above absolute zero, the coldest anything can possibly be. If you were exposed to this temperature unprotected, you would not freeze instantly. You would radiate heat slowly into the endless dark. The void is patient. It does not rush. It just waits, cold and quiet, for warmth to surrender. This is not the cold you know, the cold you have experienced. Winter nights, freezer aisles, ice cubes against your skin, is warmth compared to the void. Even the coldest place on Earth, Antarctica's polar plateau, where temperatures drop below minus 130 degrees Fahrenheit, is a furnace by cosmic standards. The difference between the coldest night you have ever felt and the temperature of deep space is like the difference between a candle flame and the surface of the sun. And yet, space would not kill you the way you might expect. In movies, people exposed to space freeze instantly. Their skin frosts over. Ice crystals form in their eyes. This makes for dramatic cinema, but it is not quite accurate. The reality is stranger, and in some ways, more unsettling. Heat requires a medium to transfer quickly. On Earth, cold air sucks warmth from your body through conduction and convection, molecules bumping against molecules, carrying your heat away. But in space, there are no molecules, nothing to touch you, nothing to carry your warmth anywhere. Instead, you would lose heat through radiation alone. Your body would glow faintly in infrared light, releasing photons into the void one by one. This is a slow process. Without air to steal your warmth, you would cool gradually, like a forgotten cup of tea in an empty room, surrendering its heat to nothing at all. The cold of space is not aggressive. It is patient. You would not feel the temperature dropping the way you feel a winter wind. You would feel the absence of everything. No pressure, no sound, no resistance. Just the slow, quiet release of everything warm inside you, radiating outward into a darkness that does not care. This is the temperature of almost the entire universe. The 2.7 Kelvin reading is not the temperature of planets or stars. Those have their own internal heat sources. It is the temperature of the space between things. The cosmic background, left over from the Big Bang, cooled over 13.8 billion years into this faint, frigid glow. Every direction you look, the universe hums at 2.7 Kelvin. A whisper of warmth from the beginning of time, stretched thin across eternity. And it is getting colder. As the universe expands, that background temperature drops. In billions of years, it will fall even closer to absolute zero, the point at which all molecular motion stops, where entropy reaches its maximum, where nothing can happen because nothing has the energy to make it happen. Absolute zero cannot actually be reached. Quantum mechanics forbids it. There will always be some tiny vibration, some residual flicker of energy. But the universe will get close, closer than anything you can imagine. The future of the cosmos is cold. Not violently cold, not dramatically cold, just quietly, infinitely cold. Tonight, as you lie beneath your blankets, warmth gathered around you like a soft conspiracy against the universe, consider what a luxury heat truly is. You generate it effortlessly, your body burning calories, radiating infrared light, fighting entropy without conscious thought. But you are the exception. Most of the universe has no warmth. Most of the universe has never known warmth. Most of the universe sits just above the coldest possible temperature, waiting in silence for stars to die and heat to fade. The void is cold and it is patient. And now, slowly, we turn towards something even more absent, the silence that cannot be broken. Sound cannot exist where you are going. Sound requires a medium, air, water, something for vibrations to travel through. In space, there is no medium. If a star exploded beside you, you would see the light, you would feel the heat, but you would hear nothing. The universe's most violent events occur in absolute silence. This is the loneliest kind of quiet, not the absence of noise, but the impossibility of it. You have never experienced true silence. Even in the quietest moments of your life, late at night, alone, in a room with no television and no traffic outside, sound was there. Your heartbeat, your breathing, the faint hum of electricity in the walls, the almost imperceptible rustle of air moving through the space. Silence on Earth is always relative, always partial, always interrupted by something. In space, silence is absolute. There is nothing to carry vibrations, no air molecules to bump against each other, transmitting pressure waves from one place to another. No water, no metal, no medium of any kind. If you clapped your hands in the void, your palms would come together, but the energy would go nowhere. You would feel the impact in your bones, but you would hear nothing at all. This is difficult for human minds to accept. We evolved in a world of sound. Our ancestors survived by listening for predators, for prey, for the voices of their families calling across open ground. Sound tells us that we are not alone. It tells us the world is alive, active, real. When sound disappears, something in our brains registers danger, wrongness, the uncanny sensation that reality has skipped a beat. And yet, the universe is almost entirely silent. Consider the violence that occurs out there. Stars explode in supernovae, releasing more energy in seconds than our sun will produce in its entire lifetime. Black holes collide, sending ripples through space-time itself. Galaxies crash together over millions of years, their spiral arms stretching and distorting like taffy. These events are among the most powerful phenomena in existence, and they make no sound. The light from a supernova can outshine an entire galaxy. The radiation can sterilize planets across light years, but the explosion itself unfolds in perfect, eternal silence. No roar, no thunder, no crescendo, just the cold, quiet flash of something massive dying without a voice. There's a strange poetry in this. Humans invented sound effects for space. The roar of rocket engines, the pew-pew of laser battles, the bass rumble of starships passing overhead. We could not bear the truth, so we filled it with noise. Our stories about space are loud because silence frightens us more than we admit. But the reality is this: if you drifted out there, far from any ship or station, you would hear nothing. Your spacesuit might hum. Your own breathing might echo in your helmet. But outside that thin shell of air, the universe would offer no sound at all. You could scream, and the scream would go nowhere. You could whisper, and the whisper would die against the inside of your visor. The emptiness does not muffle sound. It erases the possibility of sound entirely. There is a loneliness in this that goes deeper than isolation. It is not just that no one would hear you. It is that the universe itself cannot hear, has never heard, will never hear. Sound is a local phenomenon, limited to the thin films of atmosphere clinging to scattered worlds. Most of existence has never known a single noise. So tonight, as you lie here, perhaps you might listen to the small sounds around you, the hum of a fan, the creak of a house settling, the distant murmur of traffic or wind or life continuing somewhere nearby. These sounds are not ordinary. They are rare. They are precious. They exist only because you live on a world that bothered to hold on to an atmosphere. Out there, in the emptiness, everything happens in silence. And now, slowly, we turn toward the light, and how long it takes to cross the dark. Light traveling through emptiness. Light moves at 186,000 miles per second. It is the fastest thing in the universe, and yet, crossing the distances between objects takes years, centuries, millions of years. The light you see from some stars left its source before humans existed. You are not seeing the present. You are seeing the past preserved in photons, finally arriving after an impossibly long and lonely journey through nothing. This is the speed limit of reality. Nothing can travel faster than light. Not information, not matter, not influence of any kind. Einstein proved this over a century ago, and every experiment since has confirmed it. Light is the fastest messenger the universe allows, and the universe is very strict about this rule. And yet, light is almost comically slow when compared to the distances it must cross. From the sun, light takes 8 minutes and 20 seconds to reach Earth. This means when you look at the sun, which you should not do directly, you are seeing it as it was 8 minutes ago. If the sun vanished right now, you would not know for over 8 minutes. You would continue feeling its warmth, seeing its light, utterly unaware that the source had disappeared. 8 minutes is nothing. 8 minutes is practically instant. Light from Jupiter takes between 35 and 52 minutes to reach us, depending on where both planets are in their orbits. Light from Neptune takes over 4 hours. Light from the edge of the solar system, from the Oort cloud, takes more than a year, and we have not even left our cosmic backyard. The nearest star, Proxima Centauri, is 4.2 light-years away. That light has been traveling since before you started worrying about whatever you were worrying about 4 years ago. It left its source and crossed trillions of miles of vacuum, encountering nothing, touching nothing, illuminating nothing, until finally it landed on your planet, and maybe, on a clear night, on the back of your eye. That photon waited 4.2 years to meet you, and you probably did not notice. Now consider the stars you see on a typical night. Some are dozens of light years away, some are hundreds. The light from Betelgeuse, the red giant in Orion's shoulder, left its surface around 700 years ago, during the Middle Ages on Earth. The light from Deneb, one of the brightest stars in the summer sky, has been traveling for roughly 2,600 years. It started its journey around the time ancient Greeks were debating philosophy. When you look at the night sky, you are looking at history. Every star is a time capsule. Every photon is a message from the past. The sky is not a snapshot of the universe as it is now. It is a mosaic of moments, each piece arriving from a different era, assembled by your eyes into something that looks like a single image. And the deeper you look, the older the light becomes. The Andromeda Galaxy is 2.5 million light-years away. Its light shows you what that galaxy looked like when early human ancestors were just beginning to walk upright. The most distant galaxies visible to our telescopes sent their light over 13 billion years ago, when the universe itself was young and strange and nothing like it is now. Those galaxies may no longer exist. They may have changed beyond recognition, but we will never know, because the light carrying that information has not had time to reach us. This is the quiet tragedy of cosmic distance. We are always looking backward. We are always seeing ghosts. The present, in any meaningful cosmic sense, is unknowable. By the time light arrives with news from distant places, that news is already ancient, and yet the light keeps coming. Patient, tireless, crossing emptiness that would crush any human soul, carrying information from places that may no longer exist. Tonight, if you glance at a star, you are catching something that traveled years or centuries to find you. That seems worth a moment of quiet gratitude. Now slowly, we pull back even further, to see the shape of everything at once. The cosmic web and its empty bubbles. If you could zoom out far enough, the universe would look like a web. Galaxies clustered along filaments with vast, empty voids between them. These voids are not small. Some are hundreds of millions of light years across. The structure of everything resembles soap bubbles, with all the matter clinging to the edges and all the emptiness pooling in the middle. You live on the edge of a bubble, surrounded by more nothing than you could ever cross. This is what the universe looks like when you stop paying attention to the details. Up close, the cosmos seems chaotic. Stars scattered randomly, galaxies spinning in isolation, clusters here and there, with vast, empty stretches between. But when you pull back far enough, when you zoom out to scales of hundreds of millions of light years, patterns emerge. Structure reveals itself, and that structure is stranger and more beautiful than anything you might have guessed. The universe is built like foam. Imagine the bubbles in a sink full of dish soap. Each bubble is mostly empty, a pocket of air surrounded by a thin film of water. The bubbles press against each other, their walls meeting and merging, forming a complex lattice of surfaces and edges. Now replace the air with void. Replace the soap film with galaxies, and expand the whole thing to a scale so large it makes the Milky Way look like a grain of sand. That is the cosmic web. Galaxies are not scattered evenly through space. They cluster along filaments, long, thin strands of matter stretching across millions of light years. These filaments connect at nodes, where the largest galaxy clusters gather. And between the filaments, surrounded by walls of faint light, the voids yawn open. The voids are where almost nothing exists. We talked about the Boötes void earlier, that enormous empty sphere, 330 million light years across. But the Boötes void is not unique. It is simply one of the larger examples of a structure that repeats throughout the cosmos. Voids are everywhere. They are the rule, not the exception. Most of the volume of the universe is void. If you picked a random point in space, closed your eyes and pointed somewhere into the cosmos, you would almost certainly be pointing at emptiness, not near a galaxy, not along a filament, just void, cold, dark, and silent. The matter we see, the stars and galaxies and clusters we can observe, clings to the surfaces of these bubbles like moisture on the outside of a cold glass. It traces the edges, it lines the walls, but it does not fill the interior. You live on one of those walls. The Milky Way is part of a filament, a strand of the cosmic web that connects to larger structures in every direction. If you could see the web from outside, if you could somehow pull back far enough to take it all in, our galaxy would be a tiny bead on a vast, three-dimensional net. a net woven around emptiness, a net that stretches to the edges of the observable universe. And beyond the observable universe, presumably, more web, more filaments, more voids, more emptiness, extending in every direction, further than light has had time to travel since the beginning of everything. The cosmic web was shaped by gravity. In the early universe, matter was spread almost evenly, but not perfectly evenly. Tiny fluctuations, quantum ripples from the first moments of existence, created regions that were slightly denser than others. Gravity amplified these differences. Denser regions pulled in more matter. Sparser regions emptied out. Over billions of years, the web took shape, matter flowing toward the filaments like water finding the lowest ground. The voids are what remain when gravity has taken everything it can. They are not growing emptier. The universe is not draining into the filaments, but they are expanding. Dark energy is stretching the space inside them, pushing the walls further apart. The bubbles are getting bigger. The web is thinning. In the far future, the structure may fade entirely, the filaments dissolving as the universe expands toward its final, cold, empty state. But tonight, the web holds. The bubbles remain, and you rest on the edge of one, surrounded by more nothing than any journey could cross. Now, slowly, we drift inward, toward the smallest scales, toward the nothing inside everything. A single atom alone in a cathedral. Imagine a hydrogen atom scaled up so that its nucleus was the size of a tennis ball, sitting in the center of a cathedral. The electron orbiting it would be somewhere near the outer walls, a tiny speck circling at an impossible distance. Everything in between is empty, and this emptiness is what you are made of. Every atom in your body is its own cathedral of nothing. We have traveled so far outward tonight, past the moon, past the sun, through the void between planets, between stars, between galaxies. We have drifted through the cosmic web and stared into voids hundreds of millions of light years wide. The emptiness out there is staggering, but the emptiness inside is just as vast. A hydrogen atom is the simplest thing in the universe. One proton, one electron, nothing else. It is the building block of stars, the fuel of fusion, the most common atom in existence, and it is almost entirely empty space. The nucleus of a hydrogen atom, that single proton at its heart, is about 1.7 femtometers across. A femtometer is 1/quadrillionth of a meter. It is so small that the word small stops meaning anything. Meanwhile, the electron orbits at a distance roughly 100,000 times larger than the nucleus itself. 100,000 times. If you scaled the nucleus up to the size of a tennis ball, the electron would be circling at a distance of about 350 meters, roughly the length of 3 football fields. The cathedral is a gentle understatement. You would need a building larger than most sports stadiums to contain this single atom at human scale. And between the tennis ball and the speck, nothing. Not air, not energy, not some invisible gel holding things in place. Nothing in any classical sense. Just quantum probability fields, mathematical descriptions of where the electron might be if you bothered to look. The emptiness is not just physical. It is conceptual. There is no there. This is what matter is made of. Every atom in your body follows this same absurd geometry. Carbon, oxygen, nitrogen, calcium. All of them are mostly empty space, their nuclei huddled alone like solitary monks in vast, echoing halls. The electron clouds surrounding them are less like orbiting moons and more like ghosts, existing everywhere and nowhere at once until observation forces them to make a decision. You feel solid because of forces, not substance. When your hand rests on a table, The electrons in your skin repel the electrons in the wood. Electromagnetic force creates the illusion of contact. But the atoms never truly touch. They cannot touch. They are too busy being empty. Here is a thought experiment that might unsettle you or comfort you, depending on how you hold it. If you removed all the empty space from every atom in the human body, compressed the nuclei together until they actually touched, the entire human race would fit into a space smaller than a sugar cube. 7 billion people. Every thought, every memory, every dream and fear and hope, all of it, smaller than something you could hold in your hand. This is the truth hiding inside matter. The universe is empty on the largest scales, voids between galaxies, silence between stars, but it is also empty on the smallest scales. The atoms that build everything are cathedrals of nothing, held together by forces rather than substance. You are mostly void, drifting through a void, made of particles that are themselves mostly void. And somehow, despite all that nothing, here you are, listening, breathing, existing. That seems like a miracle worth sitting with for a moment. Now, slowly, we drift toward a different kind of emptiness, not the void of space, but the void of time. Time moves differently when nothing is happening. In a universe this empty, time becomes strange. There is no day or night, no seasons, no heartbeat of the world to measure against. Time exists, but without events to mark it, the concept becomes almost meaningless. Billions of years pass between interactions. For most of the universe, most of the time, nothing is happening at all. Patience is not a virtue here. It is the only option. You measure time by change. The sun rises, the sun sets, seasons shift, your coffee cools, your hair grows, your phone battery drains. Every clock, every calendar, every intuition you have about the passage of time is rooted in something happening. Matter moving, energy dissipating, the world becoming slightly different than it was a moment before. But in the void between stars, almost nothing happens. A hydrogen atom drifts through interstellar space. It has been drifting for millions of years. It will continue drifting for millions more. Occasionally, once every few centuries perhaps, it might encounter another atom. They might bounce off each other, exchange a tiny amount of energy, and continue on their separate ways. That is the most exciting thing that will happen to either of them for eons. What does time mean to that atom? The question is almost nonsensical. Atoms do not experience time. They do not wait. They do not grow bored. But if they did, if consciousness could somehow inhabit that lonely particle, what would a million years of drifting feel like? Would it feel like anything at all? Philosophers have argued for centuries about whether time exists without events to mark it. If nothing changes, does time pass? If no one is there to measure it, does duration have meaning? In the emptiness of space, these abstract questions become almost tangible. Consider the voids between galaxy clusters. Light crosses them over millions of years, but the light encounters nothing along the way. No planets to illuminate, no dust to scatter through, no eyes to enter. The photon travels in perfect isolation, its journey unmarked by any interaction, until it finally reaches the other side, or fades into the expanding universe, red-shifted into invisibility. For that photon, did millions of years pass, or did no time pass at all? Einstein showed us that time is not constant. It bends with gravity. It stretches with speed. An astronaut traveling near the speed of light would age more slowly than those left behind on Earth. Time is relative, flexible, dependent on perspective. In the emptiness, With no gravity wells and no observers, time becomes something stranger still. It becomes a formality, a dimension that exists on paper but has no practical meaning. The universe keeps its clock running, but no one is watching the hands move. This is the patience of the cosmos. Galaxies rotate once every few 100 million years. Stars live for billions. The universe itself is 13.8 billion years old, and it has barely begun. The processes that shape existence operate on timescales so vast that human history, every empire, every war, every love story, occupies less than a blink. And most of that time, nothing is happening. The universe spends most of its existence waiting for gravity to pull matter together, waiting for stars to form and die, waiting for planets to cool and life to emerge. The bursts of activity, the supernova, the collisions, the brief flowering of civilizations, are punctuation marks in an endless sentence of silence. Tonight, as you lie here, your sense of time is shaped by the small changes around you. Your breath, your heartbeat, the distant hum of a world that never stops moving. These rhythms feel natural, inevitable, permanent, but they are rare. They are precious. They are the exception. Out there, in the emptiness, time passes without witness. Eons unfold with nothing to show for them. And the universe does not mind. It has never minded. It simply waits, patient beyond comprehension, for the next thing to happen. And now, slowly, we drift toward the far future, toward the time when even the stars give up. How long until the stars burn out? In roughly 100 trillion years, the last star in the universe will exhaust its fuel and go dark. After that, the cosmos will enter what physicists call the degenerate era, a time of cooling remnants, slowly evaporating black holes, and endless cold. The emptiness that exists now will become even emptier, and that era will last longer than everything that came before it combined. 100 trillion years. That number is so large it refuses to mean anything. Your brain cannot hold it. No human experience provides a reference point. The universe is currently 13.8 billion years old, a number that already feels incomprehensible. And 100 trillion is roughly 7,000 times larger than that. The age of stars has barely begun, and already it is ending. Right now, the universe is in what cosmologists call the stelliferous era, the age of stars. This is the time when hydrogen fuses into helium, when galaxies blaze with light, when planets warm themselves by the glow of their suns. It is the era you were born into, the era that makes life possible. But it will not last. Stars are not eternal. They are engines burning through finite fuel. The largest stars burn hot and fast, exhausting themselves in a few million years. Smaller stars, like red dwarfs, are more frugal. They sip their hydrogen slowly, stretching their lifespans into the trillions of years. These patient, dim stars will be the last lights in the cosmos, and eventually, even they will fade. When the last red dwarf exhausts its fuel, there will be no more new stars. The gas clouds that once collapsed into stellar nurseries will have been used up or scattered too thin to gather. The raw material of light will be gone. What remains will be corpses. White dwarfs, the cooling embers of stars like our sun, will drift through the darkness, radiating away their heat over billions of years. Neutron stars will spin down, their magnetic fields weakening, their pulses slowing to silence. Black holes will anchor the centers of dead galaxies, swallowing whatever falls toward them, growing slowly fatter on a diet of darkness. This is the degenerate era. The name sounds bleak, but it is technically accurate. Degenerate matter is what remains when normal atomic structure breaks down, when electrons are squeezed into the lowest possible energy states, when the normal rules of chemistry no longer apply. It is matter in its final, exhausted form. And this era will last almost forever. The stelliferous era, the time of stars, the time you exist in, will occupy roughly 1% of the universe's total lifespan. The vast majority of cosmic history will be dark. The vast majority of time will pass in silence, lit only by the fading glow of stellar remnants. This is difficult to hold in your mind without feeling something. Sadness, perhaps, or awe, or a strange, quiet acceptance. The universe was never designed for permanence. It was designed for change, and eventually, the changes run out. The fuel burns, the lights dim, the long night begins. But here is something worth remembering. You are alive during the bright time. You exist in the fraction of cosmic history, when stars still shine, when planets still warm, when light still crosses the void and lands on waiting eyes. This moment, right now, tonight, is part of the universe's brief, brilliant childhood. In 100 trillion years, the last star will go dark, and nothing like you will exist to notice. But tonight, you are here, and the stars are still burning. Now, slowly, we drift toward the things that will outlast even the stars. Black holes evaporate into the void. Even black holes, those hungry giants of gravity, do not last forever. Through a process called Hawking radiation, they slowly lose mass and eventually evaporate. The largest black holes might take 10 to the power of 100 years to disappear, a number so large it does not have a name anyone uses. But eventually, even they will become part of the emptiness. Nothing escapes forever. Black holes seem like the ultimate survivors. They are the deepest pits in space-time, gravity wells so steep that light itself cannot climb out. They swallow stars, consume planets, drink down anything that wanders too close. In the popular imagination, black holes are eternal destroyers, cosmic garbage disposals that never fill up, never slow down, never stop. But Stephen Hawking showed us otherwise. In 1974, Hawking proposed something that seemed almost paradoxical. Black holes, despite their reputation for only consuming, actually emit radiation. Not from inside the event horizon, nothing escapes from there, but from the boundary itself, where quantum effects create a strange kind of leakage. The details involve virtual particles and event horizons in mathematics that make most people's eyes glaze over. But the result is simple enough to understand. Black holes slowly lose mass. Particle by particle, photon by photon, they radiate energy into the void, and anything that loses mass eventually disappears. The process is almost unimaginably slow. A black hole with the mass of our sun would take roughly 10 to the power of 67 years to evaporate. That is a 1 followed by 67 zeros. The current age of the universe is only about 10 to the power of 10 years old, a number that looks almost quaint by comparison. But the supermassive black holes at the centers of galaxies are far more massive than our sun. Some contain billions of solar masses compressed into regions smaller than our solar system. These giants will take even longer to evaporate, perhaps 10 to the power of 100 years. That number has a name technically, a Google. But no one uses it in everyday conversation, because no one has everyday conversations about timescales this vast. 10 to the power of 100 years is longer than the universe has existed by a factor so large it breaks ordinary language. It is longer than the stelliferous era, longer than the degenerate era, longer than every period of cosmic history combined, multiplied by itself, and then multiplied again. And yet, it is finite. Given enough time, more time than you can hold in your mind, more time than the word time was designed to describe, even the largest black holes will evaporate. Their mass will radiate away into the void, particle by particle, until nothing remains but faint ripples of energy dispersing into the ever-expanding darkness. The last black holes to evaporate will be the final structured objects in the universe. After them, there will be no more gravity wells, no more collections of matter, no more anything in the sense that we usually mean the word, just particles drifting apart, cooling toward absolute zero in a universe too vast to remember it was ever anything else. This is the ultimate fate of the hungry giants. The things that seemed most permanent, most powerful, most indestructible. They will outlast the stars by incomprehensible margins. They will witness eras of cosmic history that no other structure will survive to see. And then they too will fade. Nothing escapes forever. Not light, not matter, not even the traps that swallowed them. The void is patient. The void always wins. Now slowly, we drift toward the end of all things, toward the quiet that waits at the bottom of time. The heat, death is the final. Quiet. The ultimate fate of the universe, according to current understanding, is heat death, a state where entropy reaches its maximum. All energy is evenly distributed, and nothing can happen anymore. No stars, no motion, no change. Just a vast, cold, featureless expanse where the concept of time itself becomes irrelevant. This is the emptiness that waits at the end of all things. This is how the universe ends, not with a bang, not with a dramatic collapse or a cosmic crunch or a spectacular finale, but with a slow, quiet fade into absolute equilibrium. The heat death is not hot. The name is misleading. It is the end of heat, the end of temperature differences, the end of everything that allows anything to happen. To understand why, you need to understand entropy. Entropy is often described as disorder, but that is not quite right. Entropy is more like the universe's tendency to spread things out, to move from concentrated to diffuse, from organized to disorganized. When you pour cream into coffee, the cream spreads until the mixture is uniform. When a hot cup sits on a counter, its heat radiates outward until the cup and the room reach the same temperature. This process only goes one direction. Cream never spontaneously separates from coffee. Cold cups never absorb heat from cooler air to become hot again. The universe flows downhill, thermodynamically speaking, and it never flows back up. Heat death is what happens when the universe reaches the bottom of that hill. All the energy that currently exists, in stars, in radiation, in the motion of particles, in the chemistry of life, will eventually spread out evenly across the cosmos. When that happens, there will be no hot spots and cold spots, no concentrations of energy that can be tapped to do work, no gradients, no flows, no differences of any kind. And without differences, nothing can happen. Stars shine because they are hotter than the space around them. Life functions because it exploits chemical gradients. Machines run because energy flows from high concentrations to low. When everything is the same temperature, the same energy density, the same featureless uniformity, all processes stop. Not because of a law forbidding them, but because there is nothing left to drive them. The universe will still exist in some sense. Space will still be there. Time, presumably, will continue to pass, though whether that means anything without events to mark it is a question philosophers may never answer. Particles will still drift through the void, spread so thin that one might travel for trillions of years without encountering another. But nothing will change. Nothing will form. Nothing will begin or end. This is the final quiet. The timeline is almost beyond comprehension. Heat death will not occur for at least 10 to the power of 100 years, long after the last black holes have evaporated, long after the last photons have redshifted into irrelevance. By any human measure, this is eternity. By cosmic measure, it is simply what happens next. Some physicists find this fate depressing. Others find it peaceful. A universe that burned so brightly, that created stars and galaxies and planets and life, finally resting, finally still, finally done. There is a strange comfort in that, if you hold it gently. Everything ends. The universe is no exception. But the ending is not violent. It is not cruel. It is simply quiet. A long, slow exhale after billions of years of burning. Tonight, as you lie here, you are part of the universe's bright, busy middle chapter. The heat is still concentrated. The differences still exist. Things are still happening, and that, in the grand scheme, is rather extraordinary. Now slowly, we drift toward something warmer, toward you, toward what it means to exist inside all this emptiness.